Hello everybody. In this video we are going to look at the solutions to the electric, power, and energy practice problems. Let's take a look at problem number 1. A current of 5 amps flows through a flashlight bulb when it is connected to 6 volts. What is the power of this bulb? So we are given the current 5.0 amps and the voltage at 6.0 volts, and we're trying to solve for the power. So I know the power equals the current times the voltage. 5.0 amps times 6.0 volts is going to give me 30 watts. And if I want to put that into the correct number of significant figures, it would be 3.0 times 10 to the first watts. Problem number 2. What is the power in watts of an unknown device if a current of 35 milliamps flows through the device when it is connected to 3.0 volts? So this is just like the previous problem. We are given the current. In this case, we're given the current in milliamps, so we need to convert it to amps. So 35 milliamps is going to equal 35 times 10 to the minus third amps. We're given the voltage, 3.0 volts, and again being asked to find the power. So we know power equals current times voltage. 35 times 10 to the minus third amps times 3 volts is going to give me 0.105 watts. Rounded to two significant figures is 0.11 watts. Problem 3. How much energy in joules and in kilowatt hours is consumed by a 120 watt light bulb if it is left on for 15 minutes? So we're going to want our answer in both joules and in kilowatt hours. We're given the power of the light bulb at 120 watts. Because I know I need the answer in kilowatt hours, I'm going to convert that to kilowatts. So that is going to equal 0.12 kilowatts. And I know that the time is 15 minutes. And again, I'm going to want to convert that to hours. So that's going to equal 0.25 hours. I'm looking for the energy. And I know that energy is equal to power times time. So 0.12 kilowatts times 0.25 hours is going to give me 0.030 kilowatt hours. And again, use dimensional analysis to make sure that you have everything set up correctly and that you're going to end up with the right units. Now, if I want to convert kilowatt hours to joules, I know that 1 kilowatt hour is equal to 3.60 times 10 to the 6th joules. And that was in the PowerPoint that Mr. Broderick went over with you. So I multiply my power, or my energy rather, in kilowatt hours, 0.30 kilowatt hours by that conversion factor, and I'm going to get 1.1 times 10 to the 5th joules. Problem number 4. This one is very similar to the previous problem. How much energy in joules and kilowatt hours is consumed by a 200 watt stereo if it is left on for 4 hours? So I'm given the power at 200 watts, which I know I need to convert to kilowatts, so that's going to equal 0.2 kilowatts. Now note only one significant figure there. I know the time is 4 hours. I'm already in hours, I don't need to convert that. As before, I am looking for the energy. So I know the energy is the power times the time. 0.2 kilowatts times 4 hours is going to equal 0.8 kilowatt hours. And again, to convert that to joules, I multiply 0.8 kilowatt hours by 3.660 times 10 to the 6th joules divided by 1 kilowatt hour. And that is going to give me 2.9 times 10 to the 6th joules, or to one significant figure, 3 times 10 to the 6th joules. Number 5, a portable hair dryer plugged into a 110 volt outlet has a current of 10 amps flowing through it. What is the power rating of the hair dryer? Another pretty straightforward problem here. I'm given the voltage at 110 volts. the current at 10 amps, and I am looking for the power. So now power equals current times voltage, P equals IV, 110 volts times 10 amps is going to give me 1100 watts, and I need to round that to one significant figure. So my final answer is going to be 1000 watts. Problem number 6, another easy one. Don't worry, we're going to make up for this for the last 4 problems though. Let's see, a countertop convection oven is plugged into an outlet that provides a potential difference of 110 volts. What is the power rating of the oven if the current is 12 amps? So again, I'm given the voltage of 110 volts. The current is 12 amps. And once again, I am looking for the power. So as before, power equals current times voltage. So 12 amps times 110 volts is going to give me 1,320 watts. Rounded to 2 significant figures is going to be 1,300 watts. Problem number 7. If your computer uses 3.5 amps at 110 volts, how much will it cost to use the computer for 3 hours a day, 7 days a week, for 2 weeks? Assume that the cost of the electricity is 9 cents for every kilowatt of hours of energy. Let's see what we are given in this problem. We are given the current at 3.5 amps. We are given the voltage at 110 volts. We are given the amount of time that the computer is used for, 3 hours per day. There's 7 days in a week, and it's for 2 weeks. So do that out, and we end up for the total usage of 42 hours. And I know that the rate for the electricity is 9 cents per kilowatt hour. And we are being asked to find out how much does it cost to run the computer. So I know that the rate is equal to the cost divided by the energy. So if I rearrange that formula to solve for the cost is equal to the rate times the energy. And I know that the energy is power times time. So I have the rate and I have the time. I don't have the power, but I do know that the power is equal to the current times the voltage. So if I multiply the 3.5 amps times 110 volts, I'm going to get 385 watts, which I know I need to convert to kilowatts. So that's going to be 0.385 kilowatts. Now I have all of my known values. I can plug them into the equation to calculate the cost. And the cost is going to equal 9 cents per kilowatt hour. That's the rate, times the power, which is 0.385 kilowatts, times the amount of time that it's used, 42 hours, and I am going to get a total cost of $1.46, which I should round to one significant figure, so it should be $1. Problem 8. An electric heater draws 1100 watts of power. Electricity costs 8 cents per kilowatt hour. How much does it cost to operate the heater for 3 hours a day for 30 days? So again, a very similar problem. We are given the power, 1100 watts, which I know I'm going to need to convert to kilowatts. So that will be 1.1 kilowatts. The rate for which we are paying for the energy is 8 cents per kilowatt hour. The amount of time that the heater is operating is 3 hours a day times 30 days gives me a total runtime of 90 hours. And once again, we are looking for the cost. So again, the rate equals cost divided by the energy. Rearranging to solve for cost, we have the rate times the energy. And I know energy is power times time. So that's going to be 8 cents per kilowatt hour times 1.1 kilowatts times 90 hours will give me a cost of $7.92. Again, we need to round that to one significant figure, so that will give me a cost of $8. Problem 9. A hairdryer that has a power rating of 1200 watts uses 2.5 kilowatt hours in 1 week. For how many hours or minutes is the hairdryer used daily on average? This is going to be a dimensional analysis problem. We need to convert from one unit to another. So we want to convert from kilowatt hours per week to minutes per day. We could also do hours per day, but I think minutes will give us a value that will be a little bit more familiar to us. So we start off with our known values. The power consumption is 1200 watts and the rate is 2.5 kilowatt hours per week. So I'm going to start off with kilowatt hours per week, and I want to convert that to minutes per day. So I'm going to first convert my kilowatts to watts because I'm given the power in watts and the rate in kilowatt hours. So I'm going to convert my kilowatts to watts. I know that there are 1,000 watts in 1 kilowatt. And then I'm going to multiply that by 1 over 1200 watts. It might seem a little weird that we have the 1200 watts in the denominator and not in the numerator, but I put it down there so that my, hold on here, let me just get my pen, so that my watts will cancel out. If I had this the other way around, then my watts wouldn't cancel out. So that's one of the reasons why units are important and we have to pay attention to dimensional analysis. So once I do that, I now have hours per week. So now I want to convert hours to minutes and I want to convert week to days. So I'm going to convert my week to days. I know there are 7 days in 1 week, and that will give me hours per day. And now I just want to convert from hours to minutes. And if I look at my dimensional analysis here, I have weeks will cancel out. I have my kilowatts are canceling out. I have my hours are canceling out all the way over here. And I have my, what else do I have? I think that's it, right? I got them all. So that gives me 17.8 minutes per day. And I think I round around this to 2 significant figures, which will give me a final answer of 18 minutes per day. Number 10, the last one. Let's see, it's not quite 1:30 yet, so I'm actually getting better at doing these. Let's see. A clothes dryer has a power rating of 4,500 watts. How long did it take to dry a load of laundry if electric power cost 9 cents per kilowatt hour and the cost of using the dryer was 63 cents? So we are given the power consumption, 4,500 watts. We're going to want to convert that to kilowatts. We're giving the rate, which is 9 cents per kilowatt hour, and the total cost, which was 63 cents. And we want to know how long did it take to dry a load of laundry, so we are trying to solve for the time. I know that the rate is equal to the cost divided by the energy, and the energy is equal to power times the time. So if I take that formula and I solve it for time, I know that the time is going to equal the cost divided by the rate times the power. So the cost was 63 cents divided by 9 cents per kilowatt hour times 4.5 kilowatts. That's going to give me a total time of 1.6 hours.